continuation of the previous session, interconversion of energy from one form into another, that is one form of energy into another form by a physical or chemical process. Now, it is also possible for the interconversion of mass and energy in accordance with the Einstein's equation E is equal to mc square. He formulated this equation in 1905, very important equation. We can have the conversion between the mass and energy, not only among the energies, between the mass of the matter and energy. We can do conversion mass into energy, energy into mass. So this mass, if converted into energy, see that what amount of energy is liberated. Quite a large amount of energy, enormous amount of energy is liberated, because this mass is multiplied with a big factor c square, this whole square. Quite a large amount of energy is liberated in the form of heat. That is mass into energy. And this interconversion is possible by nuclear reactions, not by any chemical or physical process. What is nuclear reactions? It is the involvement of the nucleus of atom. Nucleus can be broken into pieces, that is, the heavier nucleus can be broken into pieces by bombarding the nucleus, or that is by nuclear fission, that is one way, or by fusing the lighter nuclei like hydrogen nucleus into heavier, that is one nucleus like helium nucleus, that is fusion of two or more lighter nuclei into one nucleus, the nuclear fusion. That is called nuclear reactions, nuclear fusion and nuclear fission. In both these processes, there we see a conversion of mass into energy. Some amount of mass disappear in both the nuclear reactions. That mass is again in the form of energy. That is, quite a large amount of heat is liberated in both the cases. Nuclear fission and nuclear fusion. In nuclear fusion, the amount of energy liberated will increase the temperature of the material to about 10 to the power of 6 to 10 to the power of 7 degrees centigrade. Quite a large temperature. In the nuclear fusion, it is even more. The energy conversion is more. That is, mass conversion to energy is more. If the temperature rises to even more than that, 10 to the power of 7 to 10 to the power of 8 degrees centigrade. Nuclear fusion. In nature, there you see nuclear fusion in all stars and sun. What is the reaction taking place? Nuclear fusion reaction is taking place. Once the nuclear fusion is commenced, never stopping, no stop, continuous, process is continuous. There is no stop for that. And continuous, what is that? Emission of energy. What in the energy? Enormous amount of energy in the form of heat. All around, in all directions around them. Only a part of it is coming towards Earth as a solar energy. That is E is equal to mc square mass. So in nuclear fusion, what is taking place in the sun? The temperature of the core of the sun rises to nearly 10 to the power of 8 degrees centigrade. And while you are moving away from the center to the upper, that is towards the surface, the temperature decreases to about 10 to the power of 5 degrees centigrade. And that high heat, intense heat, that high heat energy, what will do? It will make the oscillation of the atoms in the sun's atmosphere like this, dipole oscillation. So it will oscillate all the atoms, the oscillation of different magnitudes, because quite a large amount of energy is liberated. Oscillation is what is that? Even a larger magnitude and lower magnitude. So we see that with this oscillation, those oscillating atoms will generate or emit The radiations, what radiations? Electromagnetic radiations of different energies. This oscillation. So these radiations are emitting from the upper surface of the sun because of the oscillation of the atoms present in these hydrogen atoms, nucleus, helium atoms. That is the reason the solar energy, what you are receiving, it consists of all these radiations, electromagnetic radiations, gamma ray, X-ray, UV ray, visible ray, IR, microwave ray, all these radiations. We know these are not suitable for living beings. Gamma ray, intense radiations, they are tissue damages, UV radiations, and these radiations naturally are getting eliminated in the upper atmosphere by the molecules, atmospheric molecules, undergoing ionization after absorbing the radiations. And this occurs by chemical change, very important chemical change of oxygen into ozone, ozone into oxygen. So most of the UV radiations are being absorbed. Only a small dose of UV radiations reaching towards the surface. The dose of radiation penetrating into the tissue of the skin cause a chemical reaction leading to synthesis of vitamin D. Of course, it is useful. That is a dose towards this. And these visible radiations, as you know, the applications without which there is no living being on the earth, because the light, by making use of light, that radiation will cause chemical reactions in the tissues of the leaves to make the chemical reactions to make carbohydrates, proteins and fats, and these are the components of the food material for both plants and animals, without which we cannot survive. That is the importance of light. And this visible light also, that is the application, that is we can have the visibility. All animals can have the visibility because of the visible light. You can see. That is importance. And the importance of IR radiations. What are IR radiations? Heat radiations. These heat radiations will keep that is atmosphere of the earth warmer, keeping a constant range of temperature, 25 degree plus or minus, of course, less or more. So constant range of temperature. So that temperature is a must for sustaining of life on the earth. That is IR. And microwave radiations are what is coming below those, of course. So this is not of easy, what is not causing any harmful to us. That is, I am talking about the nuclear fusion in sun solar energy, mixture of all these radiations. Afterwards, we will discuss about the characteristics of all the radiations. We have not taken apart, definitely. And one of the most important things we need to discuss here, microwave and radio wave. These microwave and radio waves we are generating, we can generate them using devices, suitable materials in the devices. We can generate and transmit in the space and receive in other space. What is that other side? So you can transmit now. Okay, once it is possible to what is the space? They travel at the rate of speed of light, and you can receive anywhere in the earth. That is why for telecommunication purpose we are using these. The industry, telecommunication is important, very big industry. We are using this microwave and radio wave for telecommunication purpose. How it is just a simple principle. Using devices, there is what are the devices? Is that we are using radio wave. We are using radio wave. What is for telecommunication of what is that? Audio and video. Audio and video. And microwave for telecommunication of digits, digital information, that is internet access and any information, that is text information. Microwave are used in the transmission of digital information and radio waves in the transmission of audio and video, that is sound and vision. And these radio wave and microwave, what is that? The principle involved. What you collect the audio and video or digital information, you can convert into electrical signals by using devices. And these electrical signals will be converted into, that is, microwave and radio wave by other device, because the device contains so many components. So it is possible to convert the audio, video and digital information, and the digital information into electrical pulses into electromagnetic radiations, microwave and radio, and transmit them in the space. You can travel in the space all over. And through the satellites, nowadays using satellite, what is that? They can receive the signals, that is microwave and radio can pass anywhere in the space, all around or above, going away from the space. Those satellites can receive the electromagnetic radiations and process them, send back the radiations, send back the same radiations to the surface, so that the all surface of the earth can receive the signals. Because we can, it is not possible without satellites. If you send straight the transmission from one place to another, we can reach up to the magnitude of 1500 km because of curvature of earth. We cannot able to access by straight transmission, but is transmission, that is transmission to satellite. Satellites can have access to all the surface of the area. That is why satellite linking, through satellite we can transmit these microwave radio waves, and the satellite can transmit all these radiations all over the surface to where to receive. Can receive all over the world. The receiver is either through mobile or computer the information, and in those devices what is actually taking place, those radiations are received and converted into electrical signals, and those electrical signals into again audio, video and digital. Audio, video and digital, what is that we see in computer and mobile today, information. This is structured. Because you are using the range, what range of temperature, microwave, and this radio wave of lower frequency is not using, that is the range you are using 10 to the power of 4 onwards to microwave, that range of frequency, because one frequency, what is different, there are billions of frequencies you can create. That is why the users can use one frequency, one user, to to avoid interference. So we have billions or trillions of frequencies you can have this in nature. That is why we have receivers of billions of that is receivers can have, and transmission of the frequencies. Different companies use different range of frequencies, and individuals can use individual frequencies, one particular frequency. So this is the application of microwave and radio for telecommunication. And now let us talk about the property of the electromagnetic radiation. Electromagnetic radiation. So now the importance of electron we need to study is very important, is this property. This I said electromagnetic radiations, there is electric vector, magnetic vector. Let us take anyone, electric or magnetic. Let me take electric vector, with which, that is wave, with which let us talk about the properties. What is these properties? What is this? The distance between these 2 points, that is called one complete wave, or distance between, the 2 crests, adjacent crest, or 2 adjacent troughs, these are called troughs. It is same as this length. It is called wavelength of the radiations. Wavelength of the radiations, with which we can characterize or classify the radiations into different classes. That is why we have electromagnetic radiations of different, that is a range of wavelength. Here there is a range of wavelength because 10 to the power of minus 11, very small wavelength. Less than that, 10 to the power of minus 11 to 10 to the power of minus 12 meter, very small in nanometer, that is even less than nanometer. Gamma ray wavelength, that is small wavelength. Smaller the wavelength, higher the energy, of course. So in that range, not one signal, a range of wavelength, that is values. It is same as frequency, of course, range of wavelength. This range of wavelength is called as gamma ray, and the wavelength lies in between these range, mixture of waves. This range is called as X-ray, and radiations of what is that? Mixture of radiations of having wavelength in this range is called UV ray. This range is called as visible ray. This range is called as IR ray. This range is called microwave, and this range, that is wavelength of the radiation, even 100 kilometer one wave, bigger wave wavelength, 1 meter, 1 centimeter, 1 millimeter to 100 meter wavelength, longer wavelengths. On the basis of the wavelength, we have classified into different kinds. There is not one frequency, range of frequency. So this range of wavelength, I have classified this to this. And one more property, frequency of the radiation. I am talking about the radiation, wavelength of radiation, frequency of radiation. What is frequency of radiation? Frequency of radiation is C by lambda. What is C? Velocity of lambda, what is velocity of light? 3 in 10 to the power of 8 by lambda. Wavelength of the radiation. C by this, we get frequency. What is meant by frequency? This wave, what is that? Passing in straight line at very faster rate through a point in 1 second. How many waves like this passing through is called as frequency of the radiation. That is, through this point, I am talking about to one particular point, how many waves like this passing through this point in 1 second, it is called as frequency of radiation. So we are expecting about 10 to the power of 3 to 10 to the power of 19 waves, that is all the radiations. Radio waves about 10 to the power of 3, that is waves in 1 second passing through point, that is 1000 waves because bigger wavelength through one point in 1 second. But gamma ray 10 to the power of 19 waves. You see that millions of waves passing through in 1 second. That is the frequency of this range. And different, there is always frequencies. These are the frequency range. So range of the radiations, that is either the classification is based